All right, this is a video lesson for Unit 1, Lesson 6 in Algebra, which is combining like terms. The target is that I can apply the distributive property and combine like terms. We'll be doing the distributive property in the next lesson. So some really important vocabulary to get started. Like terms. So what are like terms? The lesson is about combining like terms. What are like terms? Like terms are two or more terms considered like if they have the same variable to the same exponent. So for example, x squared and x squared are like terms. 2x squared and 3x squared are like terms because it's the same variable to the same power. Okay? However, something like x plus y, not like terms. X and y aren't the same variable. Something like 3x squared plus 2x are not like terms because one is squared and one is not. So you have to be careful. Same variable, same power. Terms can only be combined if they're like. Constants are terms that have no variables and they're just numbers, and you can combine numbers. So constants can be combined, they're like terms. And then a coefficient is the number in front of a variable or term. So if I have something like 3x, the 3 is considered a constant. All right, so we're going to do some agree and disagree here. What I want you to do is pause the video, take a look, and see if you agree or disagree with the conclusion. I know it's silly with smiley faces, but give it a try. All right, so in this, I know we have smiley faces, but these smiley faces can be like terms, okay? There's one variable, the variable is a smiley face, and there's no exponent. These two terms are both smiley faces, which means we can add the coefficients 4 and 8 to get 12 smiley faces. These two terms are both frowny faces, and they have no exponents, so they're like terms, so we can add the coefficients to get 9 and 3 makes 12 frowny faces. And there we go, 12 smiley faces, 12 frowny faces. This one works. Now, take a look at the second one. You might want to pause again and see if you agree. For this one, I disagree. We have 2 smiley faces here. Well, really 12 smiley faces, 4 smiley faces plus 8 smiley faces. And we have 9 frowny faces and 3 frowny faces. This is a brand new variable. You can't combine x and y and get z. You can't combine 2 variables to get a new variable. So no, we don't have 24 of anything here. We have 12 smileys, 12 frowns, and no, we don't have any of these whatever indifferent faces. So this is a disagree. Okay? Try the same thing with these 2 problems. Pause, take a guess. All right, so if I have 3 apples, 5 Twizzlers, 2 bananas, and 1 apple, well, I can say that I have 3 and 1 apples to make 4 apples. But I can't say I have 3 plus 5 plus 2, what's that, 10 plus 1, 11. I can't say I have 11 apple Twizzler bananas. Combining apples, Twizzlers, bananas, and it doesn't make new variables, okay? So we can't combine things that aren't exactly alike. So this is a disagree. Over here, yes, as I said, I can combine the 3 and 1 apple to make 4 apples, and then I just have 5 Twizzlers and 2 bananas. I don't get to combine these to make some kind of new variable. So this is an agree. All right, so now we're moving into the world of variables. Same deal. Pause it, take a look, see if you agree. All right, so for these, this problem, you notice it's the same problem on the left and the right. In this problem, we have 6 and 12. 6 and 12 are both constants. They have no variables, which means they're like terms. Constants are always like terms. Then you have 6x, which is not a like term to the 6 and the 12 because it has an x. So we can put the 6 and 12 together to make an 18, but the 6x can't combine with that 18 to make a 24x. So over here, we agree. 6x plus 18. You have the 6x and the 6 and 12 make an 18. Over here we disagree. It doesn't make sense because you can't put the 18 together with the 6x. All right, so let's start doing some real examples. I'm going to do one and then give you a chance on the other ones. So for this one, I'm going to do the same thing. I have 7y and negative 3y. Keep in mind that's a negative, okay? Those are like terms because they both have a y. Then I have 2 and negative 8. Keep in mind that's a negative. I have 2 and negative 8. Those are like terms because they're both constants. So the 7y and the negative 3y can make a 4y. And then the 2 and the negative 8 can make a negative 6, giving us an answer of 4y minus 6. I can't put the y term together with the constant term, so this problem's over. Go to example 2, pause the video, and try it on your own. All right, so this one, I've got a 5x and a 3x. I've got a y, a negative 4y, and a positive y. So all of those y terms can be put together and all those x terms can be put together. I'm going to put together the 5x and the 3x to make an 8x. I'm going to put together the y's to get 1y minus 4y, that makes negative 3y, plus a y makes it negative 2y. And that problem's done because I can't put x terms and y terms together. Same thing with example 3. Pause it, try it, come back. All right, so 3x squared and 2x squared are like terms, and it's actually different for negative 7x and x because they don't have a square. They don't have that little 2 up here, so they are not like terms. So I'm going to put together the x squared terms to say 3x squared and 2x squared. You add the coefficients, so that makes a 5x squared. And negative 7x and positive x makes a negative 6x. And we get 5x squared minus 6x. You can't put these together. They aren't like terms. All right, moving on to some fill-in-the-blank questions to end our day. Okay? What I'm looking at here is that I have some x terms on this side and some constant terms, or a constant term. Okay? Over on the left side, I can match that 7. I also have a 7, so I'm good. But I don't have 5x, I only have 3x's. So the way we're going to fill the gap there is we're going to add a 2x, because when we put this 2x together with this 3x, we'll make a 5x and the two sides will match. All we're doing with these fill in the blanks, which shows up on the test, all we're doing with these fill in the blanks is putting something there that's going to make the two sides equal to each other. You can try these remaining problems and pause and come back to it, but I'm going to keep going now. Okay? So on this side, I have a 9x squared for number 2, and I have a y. They're different terms, so I'm going to underline each of them. On this side, I have 3x squared, and I'm missing 6x squareds to make it match. So if I give this a 6x squared, now I have 3x squared and 6x squared to make a 9x squared. I'm also missing that y, so I'm going to put plus y, and now the two y's match up. For number 3, this side has a 5x squared and a 10x. On this side, it has a 3x and an x squared. So it's missing 4x squareds. Since the other side has 5 and it has 1x squared, it's missing 4x squared. So I'm going to put a 4x squared. And it's missing 7x's. If one side has 10 and the other side has 3, it's missing 7x's. So I'm going to give this 7x. And now the two sides should match. Finally, number 4, this side has 10 A's and 4 1's, and the other side has 5 A's and 4 1's, so they match in terms of 1's, but this side needs 5 more A's for it to each have 10 A's. So I'm going to give it a 5A plus. And now, both sides match in every problem. And that's the end of this lesson.